Let's talk about computing the derivative function. So these types of examples are what you see here, where they give you a formula of a function. And instead of asking for f prime of a number, they just want the actual formula for f prime of x. So we're going to do two examples in this video. The first one is this quadratic function that you can see here. And the second one will be a square root function, which you can see lower down. All right, so for both of these, we're going to use our updated definition for f prime of x, which is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. That's going to be our formula every time we need to do f prime of x. Okay, so we have the limit ready to go. It's always h going to 0. And the denominator is always just the letter h. And it's going to be our job to fill in the two pieces of the numerator. The regular f of x right here, this is just going to be the entire original function, x squared plus 5x plus 2. I also need to compute f of x plus h. So I want to think for this function, f of anything is that thing squared plus 5 times that plus 2. So if I'm plugging x plus h into this function, the x plus h is going to go in both sets of parentheses that I've drawn here. Okay, so that gives us the limit as h approaches 0 of x plus h squared plus 5x plus h plus 2. All that is just f of x plus h. And then we'll have minus parentheses, original formula, all divided by h. Now, this looks pretty bad and it's about to get worse, but we're kind of trusting the flow of these problems. We're expecting that if we tried to plug in 0 for all the h's, we would get 0 over 0. So we know that we're going to try to simplify and factor the numerator, and we're just waiting for h over h to cancel. And as soon as it does, we can plug in our 0. So the first thing I'm going to do to try to simplify the numerator is just expand x plus h squared right here. I like to make that its own separate step at the beginning when it's necessary. So this x plus h squared, and I want to be really careful about expanding it so that I don't end up missing that middle term. So x plus h squared, that's x plus h, x plus h. If I FOIL that out, I get x squared plus xh plus xh plus h squared. And then these two middle terms combine to 2xh. We're going to do enough of these examples that if you remember the x plus h squared shortcut, that it comes out to this. You don't have to redo the work every time. But again, it's just important that we don't forget that 2xh term in the middle. It's a little sneakier than the rest of it. All right, so that's the only thing I'm going to update in this step. So I'm going to put this in for the circled part. Everything else will be exactly the same. In this next step, I'm going to do all of the distribution into parentheses. So that's this 5 here into the x plus h, and then this subtraction into these parentheses here. If there had been a coefficient on x squared here, I would have that number outside a set of parentheses right here as well, and I would also distribute, but it's not necessary in this problem. Okay, so that gives me x squared plus 2xh plus h squared plus 5x plus 5h plus 2 minus x squared minus 5x minus 2. Okay, so this is as expanded as I can possibly get my numerator. And this is where things start to cancel themselves out. For example, plus 2 minus 2 cancels out. I also have x squared minus x squared and plus 5x minus 5x. All right, so let's write what's left. So up top, I have 2xh plus h squared plus 5h. And I can kind of see that I'm able to do the h over h cancellation because all three of these terms have an h they could give. You can cancel this all in one step if you like, or you can factor the h out of the numerator and then do your h over h cancellation. Either way should work. I'll factor it out. So if I pull the h out in my numerator, the first term is 2x, the second is just 1h now, and the last is 5. And now I can clearly see my h over h cancellation, and I know that now I'm allowed to just plug in h equals 0. Remember, h is the thing going to 0, so I'm going to plug in 0 just right here, and the x stays an x all the way through to the final answer. So we get 2x plus 0 plus 5. So my derivative formula for this function is 2x plus 5. All right, let's try it one more time with a different function type. Here we have the square root of x minus 9, same task. So I'm going to start off with the same f prime of x definition as before. The limit as h approaches 0, f of x plus h minus f of x all over h. And again, the two pieces of the numerator are my first task here. The whole original function is going to go in for f of x over here. F of x plus h in this case will be square root of x plus h minus 9. Parentheses aren't wrong here, but they're not necessary since there's nothing like multiplying on it or any exponent. All right, so that gives me the limit as h approaches 0, square root x plus h minus 9 minus square root x minus 9 over h. And again, we've seen enough of these that we're expecting a 0 over 0 limit. So we know that now that we're seeing square roots, we'll choose the conjugate trick to figure out the limit. So I'll multiply the top and bottom times the conjugate of the square root stuff. So instead of root minus root, I'll multiply times this root plus this root. So that's root x plus h minus 9 plus root x minus 9. Same thing on the bottom to keep it balanced. The denominator is going to stay kind of the thing that I have created, but up top, we know that we have a minus b times a plus b. So that will simplify to a squared minus b squared. You don't have to do this as a separate step, but I like to just so I don't lose anything along the way. Right, so in both pieces of this numerator, the squared and the square root cancel, but the parentheses remain. X plus h minus 9, the parentheses don't have to be there because there's nothing multiplying on it, but in the x minus 9, this subtraction is in front of it, so having it grouped in parentheses will be really consequential. So that gives me x plus h minus 9 minus parentheses x minus 9. And then that denominator stays the way it was. Go. So in my next step, I'm just going to distribute this subtraction into the parentheses to get minus x plus 9. X plus h minus 9 minus x plus 9. And in this numerator, finally, we're seeing some of the cancellation that the previous problem had. So I have x minus x gone, minus 9 plus 9 gone. A good way to catch this kind of subtle minus sign parentheses issue is if your constants don't cancel, right? If we had minus 9, that'd be a red flag that we missed something earlier on. So this whole numerator is just h now, and I can do my h over h cancellation. So I have just the h left over on top. H over h cancels, and we know this is h divided by h up top, so there's really a 1 left over. And I can plug in a 0 for my h in this step. And remember, these x's will survive until the final answer. It's just right here, this one h gets filled in with the 0. So I have 1 over square root of x plus 0 minus 9 plus root x minus 9. So this denominator is root x minus 9 plus another root x minus 9. So you can leave it exactly that way. 1 over root x minus 9 plus root x minus 9. Or if you want, you can say one of these plus one of these is 2 of these. So we could also write 1 over 2 square roots of x minus 9. Either one of these is a perfectly good final answer for the f prime of x formula in this case.